Hey everyone, nice to meet you. Nice to welcome you in this room. So I'm Laurent, your room manager, and today we are welcoming Aniket and Shintan from ThredUp, and they will speak about how they modernize their data infrastructure by using Databricks.
Hello and welcome. Thank you so much for coming early in the morning for our session. Really appreciate it. Let's set the stage. I'm Aniket. I head the data platform and fintech engineering team at ThredUp. With me is Chintan. He's a manager of data engineering team. We are here to talk about how ThredUp modernized his data infrastructure over from an early stage startup to a public company over the span of last 12 years. So let's get started. So before we get started, I want to make sure that I set the environment so we all humans can actually observe and take action after the session. So let's set the stage of ThredUp. So what ThredUp is, we are the world's largest second-hand consignment store. You can think of it as a marketplace wherein we have sellers and buyers. We were founded in 2009. We're headquarters in Oakland. We have a wide variety of items on our marketplace, 55K plus items. There are 200 million items we have processed in so many years. And as of Q1 2025, we have 1.5 million active buyers. So our mission, in simple terms, is to inspire the world to think second-hand first. As we know, today's challenges on climate, we want to make sure that we do our job to make sure we are living in a planet and ensure that we make sure this entire journey of ThredUp, like right from the company and the environment, we are trying to take our part for that. So let me go over a little bit of an operating system walkthrough of our ThredUp. So ThredUp has distribution centers. We have world-class infrastructure. We have a powerful technology and software that backs it in terms of distribution center softwares. And also we have a lot of data feeds that power AI-powered experiences on the website. So let me talk over what are the buyers love on the marketplace. We have a wide variety of brands. We have a wide variety of categories. And we cater to women and kids clothing and accessories. And the sellers, I think one of the important point I want you to zoom in is the 73% of apparel is sent to landfills. We could have reused or resold 95% of it. Imagine the stats there. So what we do here, we actually give an end-to-end clean-out service. Make sure that anything in your closet which is sitting there, trying to make sure, like telling you that you can earn money on it, you just have to put in all the clothes for women and kids, put it in there, send it to our distribution center, and we can sell on our marketplace. So one of the things what we have powered is the AI search tools, which is really like, if you look at ThredUp, there is a unique problem we have. We have unique SKU. There's one of each item. There is not a SKU concept. We don't have a quantity thing. When you go to our website, we don't see like quantity 1, 2. It's only one of each item. So what happens is there is a lot of overwhelm from our customers. So what we have done over the years, we have built a lot of search tools with actually the power of data and AI. So if you look at our website, we have AI-powered search. If you go to any image, just yesterday, Apple launched an intelligence features of image search. You can take an image, browse to the web. We do the same thing. If you take an image from any website, you can browse through, take an image search, and find a similar clothing online. Plus, we have a chatbot, which actually helps you to get into like a style chat, which allows you to look at our inventory from a style perspective. Little bit of stats on the planet. One of the things which I really like about this is how much of gallons of water we have saved and how much energy, and then how much of carbon dioxide we have saved for the planet when we have started operating since 2009. So that sets the environment for us on what ThredUp is. Let's see how the data infrastructure has powered this journey of ThredUp over the years. So I'm going to talk you through the early days of ThredUp when we just started the company. A small startup trying to make sure, making a footing in this resale industry, how to sell second-hand clothes. So one of the things when we started, if you look at whenever a company starts, there are a lot of transactional databases and sources. So what our simple strategy was to put a looker-like tool which allows you to model metrics and measures and dimensions on top of replicas of MySQL. So technically, imagine you just have few databases, you put a BI tool on top of it, and you actually create dashboards and reports. So that is what the initial stage was that for 5 years. Because the data footprint was small, we were trying to ensure that we don't create too much of modern infrastructure at that point in time. And as we progressed in 2014, we thought that the data footprint was growing. Imagine like we were collecting a lot of website activities, click data, and our transactions were growing day by day. So we introduced Amazon Redshift. As we were primarily an AWS cloud, we said that, okay, let's use Redshift, let's get started on the block, and we can convert whatever models, like who on the audience knows star schema modeling, right? So when I joined the company, I came in 2014, I said, hey, let me build a star schema model in Redshift in the backend. So our head of analytics said that if you build the star schema, how can I know everything what you have built in the backend? Why can't you just build the star schema on top of Redshift in Looker? So what we did is we actually converted normalized tables and created a LookML in Looker to create a star schema. And then it powered a lot of people to just democratize exploration of data rather than it being we being a bottleneck to create data sets. So that was an empowering aspect in 2014 and 2016. So as we progressed forward, one of the biggest challenges came in 2017. Our data footprint was growing. We were saying, okay, our data scientist team was growing up. We had data engineering team and BI team. So one of the things that happened was there's a lot of data coming in. We need to run scikit models on big data, training it. So we looked at Jupyter Notebook back in the days. We said that, oh, let's deploy Jupyter Notebook on AWS Cloud, and we can try to run some data science models. That's when in 2016, around 2017, we came to know about this company, Databricks, a startup back then trying to make sure what it's trying to solve. So one of the things we liked is just a Jupyter Notebook on the cloud. That was the only feature I got wowed by. I'm like, okay, it allows you to run notebooks on the cloud and the infrastructure is managed. So in that case, the initial years of Databricks was all about for data scientists. You just run Jupyter Notebooks, you have data in Redshift, you can do a Python or Spark data frames, crunch your data, train the data, and then run the models. So that was this, as you can see, like just to summarize, 2009 to 2014, this is the simplest architecture we had, just source and BI analytics. Then what happened? We said that, okay, our modern infrastructure, we were trying to put sprinkles of a modern infrastructure. We said, okay, let's make sure we don't replicate on ourselves. We don't want to create pipelines on our own. So we looked at Fivetran, who can just replicate sources from transactional systems to Redshift. So we use Fivetran for that. And then the architecture was, okay, now let's put Looker on top of Redshift. So it is as easy as converting a LookML connection from SQL, MySQL to Redshift. So that was our transformation journey. And then when Databricks came into the picture, as you can see, the Redshift block is pretty high, right? We would still using Amazon Redshift as a main data warehouse. And initially what happened, like in that years, we started doing a lot of event bus kind of architecture, wherein a lot of microservices were sending events in Kafka and Kinesis streams. So we said that we need a landing place. So at that time, Databricks introduced Delta Lake format. So we said, okay, let's use Databricks to expand our usage from data science, Jupyter Notebooks, to Delta format. So we went into Delta format. And then that started a journey with Databricks and expanding one use case at a time. So we did not venture into like one system for everything. We ventured into little by little based on the use case. And that was a more transformative journey in our infrastructure. We didn't rush into building solutions and trying to fit everything in one puzzle. We were trying to solve one piece at a time. So right after this, I'm going to hand over to my colleague Chintan, who will go over more adoption of Databricks from Delta format Jupyter Notebooks and how it evolved over the years till now.
Yeah, thanks, Aniket. Am I audible? Yeah, okay. So yeah, we'll double click on Databricks adoption a bit more from here on, and also see like once we started working with Databricks, having that as a central platform on our, in an environment, how did things evolve after that? So this is the chart of, in 2017, what Aniket spoke about. It was mostly about Databricks notebooks and data science, a managed Spark platform being available to our data producers for the first time, ML modeling, and in 2018, 2020 is when data engineering came into the scene. We built a centralized Kafka consumer, which is on the Event Bus platform. It reads from several topics, optimizes them, and syncs them into S3. And that's when we chose Delta Lake for its asset properties and reliability and the performance measures. Like, it was better than some of the other data storage solutions we had. Moving on from there, 2021, 2022, this was a really pivotal moment in our journey when we moved from Redshift to Lakehouse. We're using an external managed Hive metastore, and things were set up on AWS instance profiles at that time, which we'll go deeper into this in a bit. The other big pivotal moment, or the other defining moment, was when we moved from Hive metastore to Unity Catalog. And we are 100% on Unity Catalog right now. And some of the upgrades happening along the way. And this is the scene today, like what we are focusing on. So let's talk a bit more about Redshift to Lakehouse migration. How did this journey go about? Firstly, like, we were on Redshift, right? So what is the need? What were the factors that led us to move from Redshift to Lakehouse? Performance bottlenecks, that was the main thing. Some queries, like some of the workloads missing SLAs and duplication of data, moving data from S3. Like S3 had our biggest, most voluminous data from event streams. We exposed them as spectrum views on Redshift, which was a performance bottleneck right there. And then on Redshift, you integrate data, build some gold layer data sets. Those had to be copied back to S3 for ML processes. So like managing such data in two places is not fun anyways. So that led us to think of some other solution where we could have things in the same place, and Databricks Lakehouse was up and coming at that time. So unified architecture of structured and unstructured data. Redshift was also like constrained by the compute it had, right? It's a closed system, but on Databricks, when we came in, we had the flexibility to choose a compute for bigger workloads. We could spin up a cluster, like there's no restrictions there. And it's also about not missing SLAs, like the jobs had their own compute, so there's no bottlenecks happening there. And yeah, all the data being in one place is always good. There's no overhead of maintaining two databases, syncing the data, and having constant requests that the data is not in sync, like I see a different metric here and like a different value on the other system. So that's what led us to move from Redshift to Lakehouse. So this is how the architecture looked like when we moved to the Lakehouse. Sorry. Yeah. So the other piece is the same, but you can see that the Redshift is pretty small, has a small footprint because our fintech team, or the finance, the numbers that goes out to the street, was still being reported from Redshift. And Databricks was the primary system for AI, not AI at that time, but ML and data processing, BI, everything was being powered from Databricks. So what this helped us with is Databricks did not come into SOX compliance from the get-go. Redshift was our compliance system where we had our governance, everything in place. We could move faster on Databricks. And not having to put in all the bells and whistles from day one, right? And Looker was primarily, our BI was primarily being powered from Databricks at this moment. Moving on, who has made a big move without any U-Haul or using the right tools? It's really difficult, right? One of the things, like the Redshift to Lakehouse migration took us 3 quarters and some more planning before that. So it's really a long process to move all the workloads, thousands of tables over. Building some tools along the way, really going to speed up the process and save headaches for a lot of other data consumers and data producers as well. in our system, we had mainly 3 things that we had to do. For the looker semantic layer, convert it into Databricks compliant SQL, Redshift to Spark SQL conversion, and a data validation utility. So these, like investing in these tools early on, planning them during the migration really helped us, because initially there might be some resistance. This is going to be throwaway work. Why do we do it? Like just after the migration, no one is going to use these utilities. But for the migration, for that scale, it's going to help you. Like, yeah, that was our experience, to invest enough and keep refining these tools as we encounter different variety of workloads. So life after Databricks, like on the Lakehouse, this was our first relationship. And as you get to know someone better, there's some pieces you like, some pieces you don't. So the things that we loved about Databricks then was mainly about Databricks notebooks. That was the first thing where people had a collaborative environment. Earlier, it was restricted to the data science team. Now, all the other analysts, data engineers, everyone was on that platform. And the collaborative power of Databricks notebooks, version control in there, ability to switch between different languages, all that was new for a lot of people. And that's what they loved. And having, like, not being bottlenecked by the compute is definitely something that people liked. And there's like lots of managed features in there that earlier we had to build some utilities tools around it to support it, but now Databricks had it. Like something like workflows, we had to manage an Airflow instance outside of it. But on Databricks, workflows saw really quick adoption because you're building pipelines in there. And just having a scheduler in Databricks in the same environment was like, I mean, it was not as evolved as Airflow. We still use Airflow for some of the cases where workloads are being triggered outside Databricks, or we integrate data from different points with Databricks. So we still use it, but workflows, like for plain vanilla scheduling, workflows work really well. Things that we did not like about Lakehouse at that point, having to keep a managed Hive metastore. It was a pain. It had its own challenges with query runs and concurrent access. AWS instance profiles. That was the biggest thing, I would say. Hive metastore, we could still live with it and have some workarounds around it. But with AWS instance profile, what happens is we provision access on AWS side and attach it to a cluster. Now, and users are given access to the cluster. So anyone having access to a cluster has access to a wide range of permissions. It was not fine-grained. It was pretty blunt-based. And that was the biggest thing. A single point would be that, what led us to move on from the current setup. And cost monitoring as well. When we were new in there, we didn't really fully understand what were the right kind of computes or workloads to choose for a particular, right types of computes to choose for a particular workload. So there, we kind of, over-consumed our budgets allocations in the first year. So this was the reason why we decided it's time to move to Unity Catalog. And 2022 was the time when we heard about Unity Catalog, got a glimpse of it at this summit the first time. And that's when we started thinking, like, Databricks had its roadmap. A lot of features were being, had Unity Catalog, like, mandatory to be on Unity Catalog. They were not available outside of it. And due to all these fine-grained access control that we needed, that's when we decided it's time to move to Unity Catalog. And zooming into the Unity Catalog migration, which was the second big migration we did, is there were things in our platform which were less than ideal. Let me keep it that way. And things that we wanted to improve on. So this was an opportunity. We just went to Lakehouse a year before that. Just the workloads are stabilized. We are figuring out what are the best practices, what are like the low-hanging fruits that we could optimize on the compute. But then with Unity Catalog migration, we had a chance to deploy Lakehouse 2.0 on our system, right? Revise quite a few things. And what were the things that we considered at that time? is how do we structure the catalogs? On Hive Metastore, there's just one catalog, everything just divided by schemas. So this was a question. How do we segregate workspaces? Before this, we were on a single workspace. How do we improve our SDLC? How do we support multiple workspaces and ensure seamless CI/CD between them, like no code changes when you're promoting something to a higher environment? How does the permission model look like? So there are quite a few things that we had to think about at that point. And workspace segregation, let's zoom into this a bit because this was the thing where we spent the most time really thinking through how do we segregate the workspaces and the catalogs under it. So this is one of the architectures which Databricks suggests, where you just have a simple dev stage and a prod workspace. Everything is like the access permissioning is centralized. The other option is by lines of business, where each line of business has its own dev stage and prod. What we realized is at ThredUp, we have centralized teams for everything. There's just one data engineering team, one data science team, one team practicing machine learning. And for every domain, we didn't have any duplication or distributed teams. So for us, it made sense to just go from one workspace to 3 workspaces, use the previous setup, like we see here, rather than overcomplicating things and really overthinking like 10 years out what would happen. I'm not really considering that. So this is how things look like. This is the legacy setup, instance profiles on the Hive Metastore, user groups, everything on one workspace. And data engineering being the one setting it up, we had the liberty to call it whatever we want to. So 2018, it was called Data Eng, D workspace, even though it was data science using it. But that was our legacy setup back then. And then this is the newer version, where all the access permissioning, the user role mapping is happening through Okta. Okta linked to Databricks, to Unity Catalog. And this thing is so seamless. Any new person joining a team, like data engineering, we are the ones who manage the governance at ThredUp for Databricks. And there's not a finger we got to lift or nothing that we have to set up. IT team provisions them, puts them in the right user group in Okta, and it gets synced to Databricks, to the particular user group there, and they get the access which is set up for those teams. So this was really seamless, and then you can see like we had a dev workspace which we introduced new, and a prod workspace where we segregated the workloads. And the DE workspace functioned more as a staging or a sandbox environment. We were even thinking of moving from DE workspace, like have a new workspace as a staging one, right? There's lots of legacy stuff on data engineering, but moving that to a new workspace was not really necessary. We just took out the production stuff from the DE workspace and created a new one. Dev was brand new, so nothing had to be done there. Here is a closer look at the workspace and catalog mapping that we did. Let's just talk about the prod. This is the prod catalog, and it's accessible in every workspace. Read, and in prod workspace, you could read and write. Now this really makes life simple for developers who want to test. Like everyone wants production quality data when you're testing your changes, right? With this setup, with Unity Catalog, we didn't have to copy any data anywhere. Just at the workspace level, you could enable a catalog, mark it as read-only, and no one could mess with it in lower environments. We were fine with read access in lower environments, and that's how, like earlier in the Redshift world, we had 2 separate environments. Every few months, you might copy some data, have like a quarter of data or something in the lower environment, and then keep moving data, refreshing it, or sometimes for smaller changes, you really don't even test it with even a weeks of production data, just some unit testing and push it out. But with this, it's all of that became a whole lot easier. Then there is the dev catalog, which is, in the lower environments, we could read and write to. And sandbox is another thing which users ask for, where they want a dedicated space where they could play around, write tables without worrying about the retention or anything. We have, we store tables, say, let that be for 12 months, and then anything that's not being used can be deleted without really getting into, do you need this table or not? Those are not really data sets not production data sets. Another thing that users frequently ask is, I have created this table in Sandbox. Can you copy it to production? And that's a big no-no because there's just a backdoor to have lesser quality data or unvetted data making its way into production. That's why Sandbox is not even accessible for read in the prod workspace. Parallel runs during migration during the Unity catalog migration, since we had a Hive meta store storing our tables, and Unity catalog was a separate copy, so it was really easy to have parallel runs on both the sides where the tabular data sets could be duplicated. But the challenge was, earlier we were using the local notebooks from the Databricks workspaces, and with the UC migration, we moved them to Git, not relying on the Databricks version control, but using Git for that. So first step was move those notebooks to Git, and then use them for the job in D workspace was the production job at that time. So use the same code base for both the workspaces, the existing one and the new one. So any changes or code drift happening along the way, new features, both the environments refer to the same code base. And so the Hive table here, table in UC here, this was fine. This was not a concern. But there are some things which we're not able to duplicate, where you're writing to a feature store, or you're writing to some S3 location, or calling some APIs. That's not getting duplicated with Unity catalog. So in the new one, we had to turn it off when we are testing. During the parallel run, that piece had to be turned off, or we control it with parameters where you write it to a different location during the parallel runs. Compare the outputs. And then once things are done, it's not visible here. You just cut off this whole part and enable this. That's what our strategy was. Now let's take a look at the latest architecture that we have. There's been a lot of upgrades in parallel to Databricks that have happened on our ecosystem. So let's see how it looks like today. Fivetran has been replaced by ET-Leap, which again does pretty much the same thing, the data replication from transactional system to the lakehouse. We've introduced Snowplow for event tracking to standardize the events. That data is the most messy and most error prone. So getting some additional tool which can ensure that the data quality improves was essential. Then you can see we use Monte Carlo for observability. So Monte Carlo coupled with Unity Catalog completes our data governance and monitoring piece. We've been on dbt for quite a while. So dbt and Databricks notebooks are the two options users have to develop their code. And Databricks SQL Warehouse powers Looker, our BI layer, Looker and QuickSight, our BI layer. Airflow is still there. Airflow is, as I said, Databricks workflows. We have been using Airflow for a while, and we feel like we want to keep that Airflow, have that option along with Databricks workflows, which has been improving a lot over time, but we still want to keep Airflow. We are planning an Airflow upgrade soon. Data, it's all stored on S3. Looker is the primary BI tool, and now we are experimenting, adopting AI BI dashboards a bit. We still want to keep Looker as the primary BI layer, but there's some cases where AI BI dashboards work really well, have a perfect use case. Anyone using Databricks account dashboards for cost monitoring? Yeah? Okay, there's a few hands here. Please use that. It's just a 10-minute. It's not even 10 minutes. It's just a 5-minute import that you need to do. And you will have visibility into where your cost is going. It's the simplest thing. If you have one takeaway, you can do it today. It's one thing. It's really easy, and it's going to save you thousands of, you'll get more visibility into what's going on. Thanks, Morgan, for sharing that. And just looking at some learnings from our journey is just looking back on the Unity catalog migration, where our CI/CD approach, going with Git, like just checking in the node, moving that notebook from Databricks local workspace to a Git was not sufficient. There are some loopholes there that we figured out along the way, and that something needs to be changed. But the takeaway there is being directionally correct most of the times is enough. That's something where we made a mistake. But the other thing where we had to support multiple workspaces and just parameterizing the catalog name here based on the workspace it is in. This was a really simple solution, but it has stayed the test of time, at least 2 years past. And we see like this approach being adopted more for different workloads. So it's like you really can't get everything right at the first go, but just if you're directionally, we are making improvements, moving from a local notebook to a Git version control notebook. That itself was a bigger improvement. And over time, we are thinking of having a build which can go back in and deploy the notebook in a separate workspace in Databricks, which has more guardrails. Project management, like for these bigger migrations, obviously engineers, analysts, they are the key people. They are the ones who are going to ensure that the details, things go right. But in such big migrations, project management, program management plays a key role where you really have to connect the dots between multiple teams, keep track of time, what's going on, how much is done, how much is left. So that really is pivotal, or it's critical in making sure that things, such migrations can be successful. If you could get some, for us, it was like we got some help from consultant specialists, and there's some Python library upgrades, which were being pushed out for quite a while. With some specialists, we got time for them to focus just on this, just on the upgrades, the Python dependency hell. Someone had to take us out of that, and we got some specialists to do that. And the initial decision of keeping FinTech on Redshift being the SOX compliant system, really has helped us to move faster with Databricks. It's like even now we feel like in hindsight, we didn't really think of what all benefits it might give. We thought several times, why should we, what is the justification of keeping this one team on Redshift and everything else on Databricks? But over time, we realized like there's quite a few benefits that we didn't realize when we made the decision. UC migration checklist, the UC migration, it was planned out pretty well for us. And when we did the actual cutover, May 21st of last year, like next 2 days, 3 days, people were in disbelief. Did we really migrate? I'm not seeing any alerts, no data quality issues, there's no jobs failing, nothing. So really preparing well on what are the pieces that are moving, and this is really going to be customized based on how your ecosystem is. So thinking through this well is going to make the cutover much smoother. Some of the other improvements we spoke about, like using Snowplow, moving from Fivetran to ETLeap, was not just for cost control, but ETLeap is a tool which gives us flexibility to transform data while in transit. You extract it from the transactional system, we can transform it on the fly and load it into Databricks. And there's some things that we learned along the way on Databricks using cluster policies, account usage dashboards, which I mentioned about. In the first year, the third point here is the workload. So in the first year, the mistake we did was using an all-purpose cluster for SQL-only computes, right, which is the costliest queue. And we didn't realize that time, but it took us a few months to realize that this is not the right place to use. So we moved to SQL warehouses and job clusters over time. Some of the core learnings are governance. Really, like when you're adopting a new technology, governance takes a backseat, and which is fine till we are trying out prototyping some things. But once there's something that's you find something, an application that's stable, it's time to think of governance. How are you going to scale this out? Because over time, it's going to bite you, and it's going to be a drag on all the other teams on letting them progress faster. So if you got to scale, you got to think of governance. And the other thing I want to really hone in on is new feature adoption. So even in the tech world, there is this notion of FOMO, right? There's tech FOMO as well. This new tool is released, I need to be there. I need to have it on. And it's going to be magical, it'll transform everything. But we really got to give it a hard thought. Do we really need this tool? Is it going to move the needle for the business? Most companies are not in the business of selling data. It's just big tech is only 5 or 7 companies that really live by data. Other companies, our company makes money by selling clothes. There's going to be manufacturing, construction, pharmacy. They're not just a platform upgrade, will not really have any business impact. So really got to think hard, what is it that your business needs, and just work towards that. I'd say that's it. And just right now, this year, we are adopting serverless SQL. Almost all our SQL workloads are on serverless right now. We are piloting Genie Spaces, conversational analytics, and AI Playground, model serving, really bridges some of the gap between data science and data engineering. So there's a lot we could try out there. That's about it. Thanks, everyone.